Welcome everyone. I forgot to hit record. Here's the answer to number 1 from the progress quiz that's posted in Canvas. We went through it in amazingly well explained detail. I just forgot to hit record. So there's the answer to number 1. Thank you. Number two is similar to number 1, except for now we have the acceleration. Still the same 3 forces, gravitational, normal, applied force. F of G is still 98 because the mass is still 10. My forces in the y direction are still balanced. Therefore my ups, 98, minus my downs, 98, have to add up to 0 because in the y direction my forces are balanced. Sum of all my forces equal to F net, which is equal to M times A. Oh, here, let's go here, I'm sorry. F net is equal to M times A, using second law. My F net is 10 times 2, because the mass is 10, acceleration is 2, my F net is 20. In Newton's second law, we can say the sum of all my forces equal to F net. Sum of all my forces means I add my rights, applied, I subtract my lefts, there aren't any. So applied minus 0 is equal to F net, or my applied force is equal to 20. My F net is 20 bigger to the right, my applied force is 20 bigger than my forces to the left, because there aren't any. Questions on that? On the desk right there's 2 more problems. I want you to grab that. I'm going to give you 3 minutes to try those, and then we'll go through that. People on the video, I'm going to try to remember to unpause it and start us over then. Let's take a look at these 2 problems. As I was quick walking around, I saw most of you were kind of wrapping up that first one, didn't quite get to that second one, but I'll kind of keep that in mind. So this is a 10 kilogram object, again, 10 kilograms, F of G is still going to be 98 because the mass didn't change, is lifted upwards such that the acceleration is 4 meters per second squared. There are 2 forces acting on this object. It is not the normal force though. The 2 forces acting on this object, there's an applied force up, it's being lifted, and there is a gravitational force down. F of G is 98, how do we know that? 10 times 9.8 F of G. The fact that they told us the acceleration is 4 meters per second up is an indicator that there's going to be an F net. My forces are going to be unbalanced. They're going to be unbalanced up because there's an acceleration that's up. My ups are going to be bigger than my downs. That's why I drew that arrow longer. We don't know the 138 number yet. Okay, that's the answer. But how did I get to that? I went through and I first determined what is the F net. The F net is equal to mass times acceleration. F net is equal to 10 times 4. The acceleration is up at 4. Therefore, my net force is 40 newtons up. My ups are 40 bigger than my downs. What's 40 bigger than 98? Because my down is 98. And Newton's second law says I add my ups, sum of all my force equal F net. I add my ups, I subtract my downs, that equals net force, which is 40. So what minus 98 is 40? 138. My gravitational force was down at 98, but my ups are 40 bigger than my downs. Therefore, my applied force up must be 138. I'll give you, I don't know, a minute while I write something on the board to do number 2 or finish number 2 if you didn't quite finish that yet. let's take a look. 10 kilogram mass is being pulled to the right at 40 newtons across the surface, sitting on a surface, normal force, such that it has a force of friction of 15 newtons to the left. So friction is something we're going to introduce today. Friction is something that opposes motion. It's going to be in the opposite direction. We don't have to get into that too much right now because it tells me it's 15 newtons to the left. 40 newtons to the right, 15 newtons left. All of the forces acting on it look something like that. Applied force is being pulled, that's an applied force, 40 to the right. Force friction, 15 to the left. Gravitational force, 98. It's not accelerating off the surface or through the surface, therefore my forces in the y direction are balanced. My normal force equals my gravitational force in this situation. And the idea of how we determine our F net and our acceleration is Newton's second law. Says I add my rights, subtract my lefts, and we can set that equal to F net. How much bigger is my right than my left? It's 25 bigger to the right than it is to the left. This is unbalanced. This is 25 bigger than that. Once we determine F net, we can then say, well, F net is mass times acceleration. If my F net is 25, that means my acceleration is 2.5 to the right. Okay. There's another sheet, full sheet right there. We're going to do some of those problems today in class together. And the rest of it's going to be homework. It's on that desk right there. We are going to introduce the idea of friction. Friction, we just did a problem with friction. If I give you a number, a value, a force of friction, all we have to do is plug that into a free body diagram or draw it in a free body diagram. But that's not very typical. When we talk about friction, friction opposes motion. It always is going to be in the opposite direction of the object's motion or the velocity. There's 4 types of friction that I can think of. Air resistance, which you don't really deal much with. There's something called rolling friction, which we don't do really anything with. And then there's when 2 things slide next to one another. And that's really the only 2 we're going to deal with. Overall, we can just call it a force of friction, but technically it's sliding friction. In order to calculate the force of friction, this is one of those equations that have their own special formula. Their own special formula is F of F, force of friction, is equal to that weird little U number, which is the Greek letter of mu, and mu is how you would pronounce it. I don't think that's actually how you spell it. It's a Greek letter, it's a variable. Mu times our normal force. So all those free body diagrams that we've been drawing, that you say, well, what do I even care about the normal force? We have absolutely, it doesn't affect anything. I'm looking for acceleration, I'm looking for net force. The reason why we need to know normal force in those free body diagrams is that's how we can calculate force of friction. It's dependent upon the normal force. This is a coefficient of friction. That's what mu stands for. It's a coefficient. It's a number. There is no unit associated with it. It's simply a value. If I ever ask you to solve for the coefficient of friction, this is the only equation that has mu in it. So you'd have to know what the force of friction is, probably through Newton's second law. You'd have to know what the normal force is from our free body diagrams, and then solve for mu. Now, real quick, friction. I can have an object that I push, I applied a force. Once it leaves my hand, am I still pushing on that chair once it leaves my hand? No. Is it still moving? Was it still moving though? Yeah, right? An object can go in that direction without being actively pushed the entire time, right? I caused an unbalanced force which caused it to move, but I stopped pushing on it. Therefore, it was no longer accelerating that way. It came to a rest. Did my velocity change or stay constant? Was moving, changed, right? Why? Because I had unbalanced force. What was the unbalanced force that caused this to stop? It's friction, right? Now, there's 2 types of friction. There is something that we can talk about when the object is sliding and moving. It's called kinetic friction. I'm pushing and it's moving. It's called kinetic friction. There's this other type of friction that's called static friction. It's when an object doesn't move. I can push really hard on that chair. I was pushing hard on that chair, but it didn't move. Why didn't it move? What was holding it back? I'm weak, so I didn't push hard enough to overcome. Glue, no, it wasn't glued down. Why didn't that thing move? Because there was friction. It's called static friction. So there's two types of frictions that we can use. On that sheet of paper, it's called free body diagrams with friction. It is linked in Canvas as a PDF. Free body diagrams with friction. Try that first line. It's giving us F nets. Based on F nets, you should be able to fill in those values. Based on those values, you should be able to, given the F nets, you should be able to determine what A, B, C, D, E, F, G. This should look really familiar. These are exactly off another worksheet, but unless you memorize the answers, it's still good practice. And we'll go through that in like seconds. All right, let's go through this top really quick. If my F net is 0, are my forces balanced or unbalanced? Balanced. Which direction are they balanced? X, Y, or both? Both, right? So if my forces in the X direction are balanced and I have a force of 50 to the right, what's A have to equal?
50.
And what does B have to equal?
200.
Because my ups are also balanced with my downs. What about the second one? If my F net is 900 newtons up, are my forces balanced or unbalanced in the X direction? In the X direction, notice how I said.
Balanced.
They're balanced, yeah. Now there aren't any forces, but they are equal, they're balanced, right? What about in the Y direction?
Unbalanced.
Which direction are they bigger?
Up.
How much bigger?
900 more.
So they're 900 more, therefore C is gonna be 1100. What about the next one? 60 newtons to the right is my, or I'm sorry, 60 newtons left is my net force. Are my forces in the X direction balanced or unbalanced?
Unbalanced.
So how much bigger is my left than my right?
60.
Therefore D is,
20.
what about in the Y direction? Balanced or unbalanced?
Balanced.
So therefore E is,
300.
you doing okay with these? Oh, one person in the room is. Everybody else doing okay?
Let's go.
Okay. What about this one? 300 newtons right. What's true about my forces in the X direction? Balanced or unbalanced?
Unbalanced.
So G is going to be,
50.
because it has to be 30 bigger to the right and the left. What's true about F and H? Are they balanced or unbalanced?
Balanced.
So therefore, they're going to equal one another. Okay. Now you get it. All right, I got some time. So we read through the problem. The idea is we read a problem, we draw a free body diagram, we can fill in some numbers. A rightward force is applied, okay, that's saying there's an applied force, to a 6 kilogram object. I often like to draw my 6 kilograms in there, but whatever. To move it across a rough surface at a constant velocity. I'm going to highlight that because that is going to be something important to remember. The object encounters a 15 Newton frictional force. The fact that I said 15 newtons is why that number is right there. Use the diagram to determine the gravitational force, normal force, net force, and applied force, and neglect air resistance. Okay, so are my forces balanced or unbalanced?
Unbalanced.
I'll give you a clue. Constant velocity.
Balanced.
Balanced. In which direction? The X, Y, or both? Both, right? I have constant velocity in the X, means my forces are balanced in the X. I have constant velocity in Y, means my forces are balanced in the Y. So what's my applied force need to be then?
15.
Because my rights minus my lefts have to equal an F net of 0. Okay? F net is equal to M times A, so M times A is F net. So because my acceleration is 0, my velocity is constant, therefore my acceleration is 0. Because my acceleration is 0, my F net is 0. Because my F net is 0, my forces are balanced. My rights equal my lefts. Fg, there's a formula for Fg that says M times G. I hope I'm remembering this number right from yesterday. I think 6 times 9.8 is 58.8 newtons, I believe. So therefore, my F of G is 58.8 newtons. Am I right with that? Let me check that. Am I good? Yeah? Okay. My forces in the y direction are balanced or unbalanced.
Balance.
So therefore, my ups minus my downs have to equal 0. So this also must be 58.8 newtons. All right. Whew, still got time. Whatever we don't finish now is homework, so I want to get through this last one. A rightward force is applied to a 10 kilogram object to move it across a rough surface at a constant velocity. Constant velocity because this says constant velocity. That told me that was going to be 0. Because my acceleration is 0, m F net equals m times a. M times a is 0. My forces are balanced or unbalanced.
Balance.
Okay. Now, new mass, F of G is equal to 10 times 9, m times G. F of G is equal to m times G. So that's 10 times 9.8. Our F of G is equal to 98 newtons. So this is 98 newtons. What's my normal force? 98 newtons. What's true about these two forces? They're going to be the same. We don't know what they are yet. So in order, we're going to know that these are going to be the same because Newton's second law is going to say mass times acceleration. Acceleration, if we add our rights and we subtract our lefts, they have to equal one another. Therefore, they're going to be the same, right? That's what balanced forces means. So in order to calculate or determine this, we can use that special equation, I guess we could call it, that I have written on the board. And our equation for force of friction is mu, which I'll highlight in yellow, which is given up here in yellow too. Mu is the coefficient of friction. So the fact that this says it's 0.2 is why on their diagram they wrote it right here as 0.2. So my force of friction is equal to 0.2 times our normal force, which is 98. Our force of friction, that ends up being 19.6. Because my forces are balanced, my applied force must be 19.6 newtons. Now, I want to flip this over. I just want to talk in general terms. I'm not going to do any more on the back, but I want to talk quick about a couple on the back. If we look, the back of this is homework. Shouldn't take you super long, but it's important for us to kind of be moving forward. Similar situation of what we just had. However, now there is an acceleration to the right. So therefore my forces are going to be unbalanced to the right. New coefficient of friction. In this problem, I'm asking you to solve for what is the coefficient of friction. So you need to fill in that value. The only equation that has mu in it is that one on the board. So you're going to have to determine force of friction and normal force to then solve for that mu. The last two problems are just word problems that you need to draw a three-body diagram for. Leave me alone. Get it? Leave me alone. Okay. Anyway, leave me alone is sledding with his friends. The idea is there's an acceleration. You're drawing a three-body diagram. From there, you can fill in all the information. If you have questions on this stuff, please let me know. We want to have this good so we can move forward on Monday or Tuesday. Have a great one.